Hi, my name is Jacob Pushy, and today I'll be discussing with you the pasta rocket lesson. For this lesson, we were told to place hydrogen peroxide and active dry yeast, which I have here, active dry yeast, hydrogen peroxide, in a mason jar, with a perforated hole in the middle of the top, and then a noodle atop that hole, which I have here. So the hydrogen peroxide and yeast are said to react once the flame is placed above the noodle. Once they're reacting down there, the noodle will begin to burn, and the noodle will act like a fuel. I will explain this reaction between the hydrogen peroxide and the yeast, and why this reaction allows the noodle to hold a flame the way it does. I will now show this demonstration of this experiment being performed. So here I have my mason jar at the top with the hydrogen peroxide in it. I then will place the active dry yeast inside of it. And then what you want to do is make a seal like the video said. And what we'll do is we'll give it a little stir, just as they did in the video. And then, keeping that seal, place the noodle on top here, like so. Oh, come on. And then, what you'll begin to notice, the noodle burns. That's pretty cool. Alright. So, how does this work? If we take a step back, in a general sense, catalysts work by providing a place where reactants can come together to react. The cells in active dry yeast and other organisms contain a catalyst called catalase. Through normal cell processes, living things produce hydrogen peroxide in their cells, but hydrogen peroxide is a poison, so the cells need a way to break it down very, very quickly. This is where a catalase comes into play. Cells contain catalase, which breaks down hydrogen peroxide at a very fast rate where it otherwise would have been a very slow rate. A single molecule of catalase can catalyze the breakdown of millions of hydrogen peroxide molecules every second. It's pretty crazy. So the catalase in this reaction, the yeast, is not part of the equation, as it does not enter the product, so it is not included in the equation, but it does accelerate the reaction itself. This reaction being the breakdown of hydrogen peroxide into oxygen and water. So the reaction taking place is H2O2 yields H2O and O2. So this reaction is taking place is a decomposition reaction. So the hydrogen peroxide is decomposing into oxygen and water. It's also an exothermic reaction because it's putting off heat, as you saw. So, to recap, hydrogen peroxide is very unstable. So over time, it breaks down into water and oxygen. In this experiment, yeast was added to hydrogen peroxide to speed up the decomposition process, which normally is quite slow. The oxygen from the reaction then rises into the hole below the noodle and then allows the noodle to stay lit by the oxygen fueling the flame, and the noodle also supplying some fuel for it to burn as well. It continues to burn and creates the pasta rocket that we see. So, the oxygen from the decomposition of hydrogen peroxide accelerated by the yeast is what's causing the noodle to continuously be allowed to burn. The reaction, in addition to being a decomposition reaction accelerated by a catalase, is also, as I said earlier, an exothermic reaction because it's giving off heat. And that is the end of our lesson today. I hope you learned a lot about catalysts, decomposition reactions, and exothermic reactions. Thank you.